Good afternoon, everybody. My name is Mark Reid from KOREC Group, and I'm going to be doing the CICS webinar for you today. Today, we're going to be talking about mobile mapping, and we're going to be talking about the various different applications that it can be used for. You can see my title there, from potholes to pole position. So we're going to be looking at how the technology can be used for things like pavement condition assessment, all the way through to how Formula One are using the technology to create digital twins of race circuits. We will be recording the webinar. It will be available on YouTube on the CICS channel, and we will also distribute a copy of the slides post presentation. So if we get started, quick agenda for the meeting. I'm going to quickly introduce myself, a quick introduction to KOREC and Trimble. For those of you that haven't, not aware of mobile mapping, I'm also going to do a quick introduction to mobile mapping, what it is, why it's important. And then really the main part of the presentation is going to be looking at some of the different applications that technology is used for, how it's kind of very much widely adopted these days, and the kind of the variety and diverse applications that it can be deployed for. And then towards the end, we'll have a quick summary, and hopefully there'll be some time for some questions. When we come to questions, if you just want to put them in the chat, then I'll try and answer as many of those as I can at the end. So just to get started then, a quick introduction to myself. Some of you might know me already, but my name is Mark Reid. I'm the UK Sales and Marketing Director at KOREC Group. Been in the survey industry pretty much my whole career since leaving university back in 2000. First part of my career was working for survey companies, and the second part of my career, I've worked for manufacturers supplying survey and mapping technology. And I've been with KOREC Group now for about 6 years, of which I've been the sales director for about the last 5. But throughout my career, really, since starting, I've always been involved in kind of laser scanning and mass data capture technology, starting with in the early 2000s, actual airborne LiDAR capture for Railtrack Scotland and mapping all the rail. That was using a Fugro fly map system. Back in the early 2000s, that was probably around about 15 points a square meter, and actually recording video on VHS videos. So that kind of shows you how long ago that was. Moved on from there to spent 6 years out in the Middle East in the oil and gas industry, helping Qatar Petroleum to document all their offshore and onshore oil and gas facilities using terrestrial laser scanning technology. Back in, I think it was 2012, I came back to the UK, and that was really the first time I started getting into mobile mapping technology when I joined MDL, which later became Renishaw, and they specialized in solutions for mapping the mining and quarry environments. So that's actually an MDL Dynascan system, which was used for measuring quarries, mapping volumetrics of stockpiles, and was really the forefront from the MX2 that Trimble launched some years later. And that really then kind of moved on from there to working at Geoslam. I was the VP of Product and Chief Operating Officer there. And that was a really exciting opportunity to bring the very first kind of handheld SLAM mobile mapping solutions to market for mapping indoors or GNSS denied environments. And I think very much SLAM is commonplace now in the industry. However, kind of 10 years ago when that original ZEB1 first came out there, it was very much a novelty, and it's amazing to see how the technology has developed, which has kind of led us up to present day with me here at KOREC working with Trimble, and really the latest in mobile mapping technology that's currently available on the market. And it has come on a long way over the kind of 25 years that I've been in the industry, and hopefully I can kind of give you a bit of a snapshot of that today. The final part that I just want to mention here is I also manage our KOREC Professional Services division, and that division is all about making mobile mapping accessible. It's about actually working with our customers to implement mobile mapping and actually understand how mobile mapping can solve the challenges that they have. And that's really where a lot of the projects today have come from, where we've actually worked very closely with our team and the customers to understand where mobile mapping is suitable and where we can deploy it successfully. So hopefully solutions and the applications you talk about will be very relevant today. Just very quickly then on KOREC. So like I say, at KOREC, we are a supplier of technology. Our mission is to empower people to measure, map and manage the natural and built environment. And we do that by supplying technology, but also coupling that with our expertise and our knowledge to make people successful with it. And that really comes through to our objective as a business. Our promise is all about providing that support and service to make people successful and get the most from the solutions that they use. At KOREC, we supply, let's say, survey and mapping technology to a vast range of different industries and a vast range of portfolios, from survey, construction to mapping GIS through to rail and monitoring. And we'll work with people which could be surveyors, we could be working with local authorities, asset owners. And what I would say is actually mobile mapping is applicable to all of those. You know, when we look at some of the applications in a minute, you'll see it's very, very diverse and covers a lot of different industries where we can actually deploy the technology. KOREC primarily is a distributor of Trimble, but we also do represent lots of other manufacturers, particularly drone manufacturers, monitoring solutions and software. So very quickly then, just on Trimble before we get into mobile mapping. So I think most of you will be aware of Trimble. Trimble are the world's largest manufacturer of positioning and measurement technology. Are used across a lot of different industries, whether that is survey and construction through to agriculture, utilities, transportation. It's very, very varied. They are a $4 billion company, and they actually invest around $500 million a year in R&D. And that has really helped drive a lot of the development that we see in technology in the survey industry, and particularly around GPS, laser scanning, inertial measurement units, and really mobile mapping is at the pinnacle of that, because it brings all these different sensors together and puts them all into one solution that we can then benefit from on our projects. At Trimble, they like to focus on connecting the physical and digital worlds. And again, mobile mapping, when we look at it, it's a very efficient and fast way of creating a digital representation of reality. And that's what, when we talk about digital twins, that's what we mean. We're talking about creating a digital representation of reality. So we can use these survey tools to map the environment digitally. We also quite often want to be able to take the digital into the field and do it the other way. So we might have 3D design information that we maybe want to verify against. So that really answers the what part of, you know, how do we use digital survey. But one of the things with mobile mapping, as you'll see, is we capture huge amounts of data, and therefore we need a place to put that. And that's what we're seeing is a real growing adoption of cloud sharing, common data environments, where all this information that we capture can go, that people can then access. And really that information is then giving them information on which to make decisions. So it's kind of answering the question of why. So that applies to lots of different technology, but it also very much applies to mobile mapping. So let's get into mobile mapping. So mobile mapping, you know, why is it important? You know, if we focus on, you know, the traditional elements of mobile mapping, which is very much, you know, road mapping, typically talking about, you know, surveying an environment that's difficult to access, that can be unsafe. It's very busy. You've got congested roads. You might not have places of safety. So generally, when we're talking about surveying kind of road and urban environments, we have to generally close a road. We have to have traffic management, which can be very costly and take a long time to arrange. And it can actually have a big impact on a project delivery by all these barriers that we have in place to survey this type of environment. Whereas if we start to look at mobile mapping, it really helps us address those challenges by offering a technique where we can actually survey an environment at normal traffic operating speeds. This means we can survey these environments faster, we can do them safer because we don't need boots on ground, and we can capture data sets much more efficiently, which directly has an impact on project delivery, times and costs. But it also allows us to capture more accurate data, reduce our site visits, and even reduce carbon footprint, which is a huge driver these days in the industry as well. So there are many benefits of deploying the technology, and it really overcomes a lot of the challenges that we face. And I think that's one of the reasons why we've seen, you know, great adoption of the technology over recent years. So just to quickly look then kind of how far we come. So one of the first mobile mapping systems that we had here at KOREC was the MX8, which was launched around about 15 years ago now. I think it's about 2010. And you can see there, you know, state of the art at the time, but a very large sensor system. I think it was, well over 70 kgs in weight. Needed a very dedicated vehicle to operate it. Pretty much limited to working on roads. In the back of the vehicle, you pretty much had a full office setup, a server rack for recording the data, and it was limited in its application. And a great product that's still being used today, but we've come a long way from this in terms of what the hardware can do and the versatility of it and how it can be deployed. The other thing that we used to see is these systems capture huge amounts of data, terabytes of data. So what very much used to happen is that data would be used to create the traditional CAD or GIS deliverables that people wanted. And then all the laser data, imagery, everything that we've captured then gets put on a hard drive and stored in the corner of the room. And again, I think this is another area where we've developed a lot away, where now we're actually producing more detailed deliverables, but actually we're hosting and sharing all of the rich laser and imagery information online with lots of different stakeholders to maximize the value of the data that we're getting at. And hopefully that's something which I can share today. So just to kind of give you a feel for where we are today, just a little video, hopefully you can see that, just kind of showing what we're talking about. So we're now talking about mobile mapping systems that are lightweight, agile, can be deployed on different systems, operated at normal traffic operating speeds. We have software which allow us to convert that data quickly and easily into usable deliverables. You can see there we're now operating from tablets and small devices, and we have solutions which allow us to share the information online with many different stakeholders. So you can see there's been some huge progress in a relatively short period of time, and I think that's really why we're seeing a massive increase in the adoption of the technology. If we start to look then at what we have, so obviously we're Trimble distributors. I'm going to talk about the Trimble solutions. There is a range of different solutions from the MX7, which is very much around capturing imagery, so that captures 360 panoramic imagery, very much ideal for kind of GIS type applications, a bit like Google Street View type imagery. You've then got the MX50 and the MX60, both systems capturing LiDAR data and imagery, coupled with high-end inertial measurement units, different levels of resolution depending on the project that you're using for. And then you've got the top-end system, such as the MX90 there, capable of capturing huge amounts of data at very precise accuracies. So again, it's not one system for everything. There are a range of systems suited for different applications and different needs. And you can see here, we've gone from 70 kgs previously on an MX8 now down to as low as 11 kg or typically in the region of around 30 kg for a full-blown mobile mapping system with LiDAR and imagery. And that really enables the solutions to be deployed on many different types of platforms, capturing up to 3.6 million points a second now in the systems with ranges up to 475 meters. Imagery sensors have come on a lot now as well. So latest solutions are capturing 72 megapixel imagery and the ability to add on lots of other sensors. So huge amounts of data that we can capture. That's not always a good thing. You capture more data, you've got to manage more data, you've got to process more data. So very much when we look at a project, you want a balance of getting the right data for the right project that's going to help you deliver as efficiently as possible. If we then look at platform, so like I said, historically, mobile mapping was very much limited to vehicle, but as the systems have got smaller and lighter, it is possible to deploy on many different types of platform. You can see there systems on trains, on boats, quad bikes. The bottom left one, there's even a trolley. So it was an area where you couldn't actually deploy with a vehicle, so we were able to mount the system on a trolley and push it around the environment. So it really does open up the potential applications of the technology. So when we look at the capture side, like I say, typically we're looking at capturing at normal traffic speeds. Obviously, the slower you go, the higher the resolution you capture. You can see there, typically now we're operating from a small device, a simple tablet. This is where you would set up the profile of how you want to do the survey. It's where you get live information from the sensors. So you can see the imagery and the LiDAR that's been captured. You can operate the system and start and stop it and capture the information that you need. Once we've captured the data, there's various software to allow you to optimize that, to integrate it with GNSS RTK corrections to get the most accurate position possible, and then actually generate all the rich point cloud and imagery that we need. And then once we have that information, we need tools in which to extract the information, to create the drawings or the models or the GIS information that people are after. And this is an area where we've seen huge progression in recent times. You know, the software has developed a lot, but also with the introduction of AI now, which is affecting all industries, it's really helping us to evaluate and extract the value from massive amount of data very, very quickly and efficiently. So, you know, that's an area that is progressing very fast, and certainly we're seeing that, and there's a lot more to come on how AI can help us work with all this data that we're now capturing. And then the final part of it is like I say, is sharing that information with stakeholders. So, you know, historically, like I say, we would give the drawings to customers, and it still happens now. We'll supply all the imagery and LiDAR, and it'll sit on a hard drive somewhere. So the objective now is, how do we actually make that available? How do we give people access to it? And what we find is, by doing that, people can actually find more and more uses for the same technology. So if we get into the applications then, if we start with probably what is the most, I suppose, most commonly used application, which is topographical surveys. So, you know, generally topographical surveys are being undertaken through traditional survey methods. Could be total station, GPS, maybe terrestrial laser scanning. Here we're looking at doing topographical surveying through mobile mapping. We're getting involved in projects which could be as small as 2 or 3 kilometers, or you could be doing full large network mapping. And the piece here is that, you know, traffic management is generally the big driver for this. You know, you could be looking at paying tens of thousands of pounds for traffic management to do a small, you know, topographical survey for a junction update, whereas actually with mobile mapping we can capture that data very, very efficiently. When we do topographical surveys, quite often there'll be the use of ground control points. Generally, mobile mapping is working off post-process GPS, which you can get very accurate results, but we can improve that actually further through the integration of ground control. And through using ground control, you can get very, very similar accuracies to what you can using traditional methods. You can see here the imagery with the CAD topo overlaid. Again, the imagery is very valuable and I think sometimes overlooked. And I think, again, with the developments in the kind of the sharing solutions, the imagery is now being utilized far more. You know, generally it used to be that people will use the topo drawing in AutoCAD or MicroStation format, but now we can use solutions like this. So this is actually a sneak peek of the new Solvo platform, which is commercially available next week. And this is where we're actually bringing all that mobile mapping data and other data sets together in a 3D environment in the cloud. So this is about actually sharing and hosting all the data in the cloud to both store it for yourself, but to also actually share it with your customers. And because it's a fully 3D environment, it means you can start to bring together all the different data sets. So you could have your mobile mapping data, you could have drone data, you could have CAD or utility data, all in the same 3D environment, and then actually start sharing that with your stakeholders and accessing it. And you can see here, very similar, a bit like a Google Street View type environment, simple to navigate and look around your data and explore the data set, load up the point cloud data as well as the imagery data, and then start to take basic measurements such as positions, heights, locations directly within a very straightforward, simple environment. So, you know, this platform and other similar platforms that we supply again, really do make the data accessible and allow people to access and get much more value from the data set that has been captured. If you start then looking at other applications, so here we're going to look at kind of pavement condition inspection. Many of you might know that at KOREC, we've been involved with National Highways and the Concrete Roads Programme. On the previous framework of the Concrete Roads Programme, there's been very much focused about how do we manage our concrete roads, which are now end of life. So the previous framework, which has actually just come to an end, was very much focused on life extension on concrete roads. So to do that, what they need to do is they need to understand the condition of the existing concrete roads, where the defects are, and therefore how do they prioritize the repair of those concrete roads. So we got involved to actually look at how this could be done more efficiently using digital solutions, because it's very much aligned to National Highways Digital Roads Roadmap, which is all about employing digital design, digital construction and digital operation. And working with the different stakeholders, we developed a end-to-end digital workflow where mobile mapping was very much at the core. So starting by actually surveying all the concrete roads using mobile mapping with the MX9, hosting all that information in the cloud, then making that information available to the various different contractors for their design purposes of how they're going to manage the repair. And then actually all the way through to then tracking the repair, documenting the repair, and feeding that back into the same cloud hosted environment. And what that does is it really gives you that kind of golden thread of information that goes all the way through the repair and maintenance process of the highway. So what you can see here is, again, utilizing the MX9 mobile mapping system for data capture, so full traffic speed, no need for road closures, no need for people on the ground. We were then capturing all of the concrete road network in the UK. So you can see all the different sections in red around the UK there of concrete road that have been surveyed. They've been repeatedly surveyed over the years, so we can understand degradation of those roads as well. And what we get from that is point cloud. So we've got the high resolution 3D point clouds, as you've seen previously. We can use that to create 3D CAD drawings, as you've seen previously. But also in this project, there was instances where they have what they call asphalt overlay on concrete. So you have a concrete road with asphalt over the top, and there was a need to understand where the junctions are in that topo as well. So the mobile mapping, it is possible to add on other sensors. So in this case, a GPR sensor. You can add on thermal sensors, higher resolution cameras, noise sensors. And this way we were actually able to not just map the surface of the road, but actually also with GPR to map where the joint locations are below the road. And using the same technology, we commonly use mobile mapping to look at things like utilities and also defects in the road using GPR. So by adding different sensors, you can really build up a very detailed picture of the environment. Now, what was really important on this project was the imagery. So obviously we have the panoramic imagery, but on the most of the mobile mapping sensors these days, we also have a high resolution pavement camera. And it's that pavement camera that we've used on the concrete roads framework to start identifying where all the defects are using AI. So you can see here an AI engine that we trained. We worked with AECOM and their pavement engineers to actually go through and label thousands of images of different defects on concrete roads. And doing that, we were able to train an AI model to automatically identify all of those defects from the data, from the images, and then project those into their spatial location. So from that, what it means is we can then produce a very, very detailed map of all of the defects on the road and their positional location very, very quickly. That information then feeds in to all the contractors, feeds into the deterioration model, and allows us to understand and prioritize the investment that's needed on the roads and which roads need to be repaired first. Again, similarly, that information is all uploaded into a cloud platform. You can see here the K platform, KOREC K portal that National Highways use. So in here, they can access the LiDAR information, They can also access all the panoramic imagery that's being captured. They can access the pavement imagery, the high resolution imagery. And within there, they can also access all the LiDAR in 3D. So they can go in, they can isolate different areas. So generally, we will segment the data to different classes. So you could have the road in this instance isolated. We also have vegetation, structures, and so on. Take basic measurements, points of interest, and actually also load up the defects that have been identified through the AI. So you can see how actually it's the portal and the ability to access the data that really adds a huge amount of the value. Just capturing the data on its own is only part of the process. To make it valuable, to have an impact on the project, we have to make it accessible. There was a project, an independent report done on this project, which was quite interesting, which really looked at, the cost saving by using this digital approach on the concrete roads framework, and it was found that around £124,000 per scheme could be saved by implementing an end-to-end digital solution. Which, if you calculate that over all the schemes, you're potentially looking at a saving in the region of 13 million across the whole framework, and once all the schemes are updated. So it's a massive potential impact by using this kind of technology, and it's only really the start of the process. To date, the pavement inspection has been largely based around imagery. However, with the more recent developments in Trimble Business Centre and some of the work that we've been doing, we're starting to actually utilise the LiDAR and the imagery. So there's certain defects that you will see in imagery that might not be visible in the camera or by the naked eye. So therefore, we have to use the LiDAR data as well, because in LiDAR, we can actually start to see depressions or rutting in the road that maybe you can't see in the imagery. So the latest pavement inspection tools that we have now utilize both the LiDAR and the imagery to create really detailed inspection reports of the roads. So we can drive the road, and then using the imagery and LiDAR, we can create a map of the defects, as well as an actual condition report where we split the road into sections and show the level of severity of each lane of the road, which can then be used to, let's say, inform the investment, prioritize the roads that need to be worked. So pavement condition inspection is definitely an area that's moving at a pace, and we're seeing greater adoption of the technology. I'm going to talk now a little bit about fibre to home. Again, it's something that's been quite a hot topic for the last few years. A huge challenge to roll out fibre to all the premises in the UK and Ireland. It also a big challenge in that to design a large network like that, you need information, and a lot of it to start with would happen from Google Street View or out-of-date data, which was having massive implications for the planning, leading to unrealistic kind of timelines and costings. So within this area, there's been a big kind of utilization of mobile mapping to say, okay, how can mobile mapping and capturing lots of data can help inform decision making and speed up the rollout of fibre. And this is a particular project that we've been involved in over in Ireland for National Broadband Ireland. They have an objective of rolling out fibre to every premise in Ireland, which is around 560,000 premises. And that in itself is a huge task over a 7-year period. It's probably one of the largest telecom projects in Ireland and one of the largest in the world. And quite uniquely, they are hanging the fibre on the poles rather than actually digging it up in trenches. So this causes unique challenges in itself, in that one of the biggest drivers for kind of delivering this kind of rollout quickly is actually the pre-works. So if you're going to hang the fibre on poles, you need to trim the trees back. So the way of speeding up the project is to get the tree trimming done before any installation happens. So initially what they were doing was using traditional field work, walking the routes, taking photos, individually, subjectively assessing where they think the vegetation might need to cut back. And what they were seeing is potentially upwards of 30% variance between kind of what they believed they needed to trim back and then what actually was needed to trim back once they got on site, which was having massive implications for program time and in cost. So that they needed a better way of doing it. And again, mobile mapping came in. So here we implemented a methodology of data capture, capturing thousands of kilometers of existing network across the country, and then linking that with a quite advanced fiber network modeling technique, which would enable us to model where the fiber should be relative to where the existing vegetation is. So you can see here, we get an existing picture of where the existing poles and wires are. We then need to model where the fiber is going to be, and that includes actually calculating the sag of the cable. So it's not where the current cable is, it's where the new cable is going to be. And then once we've modeled where the fiber is going to be, we can then automatically identify the areas of encroachment. And the reality is you're not going to go and chop 2 meters and then go a meter and chop another 2 meters. You're going to do it in stretches. So we group those together to calculate an amount of tree trimming that's needed on every span. Again, you can see here the commonality. That information is then hosted in a cloud platform. So the contractors can go in and they can see the measurements that's been calculated, but they can actually go in and see the information that is behind that. So they can load the panoramic imagery, they can actually load the point cloud, and they can actually also see the encroachment areas in 3D, as opposed to just relying on the spreadsheet of tree trimming that's been provided. So it provides a lot more certainty. And also, as you can see, that the richness of the data means that the data we can use for lots of other applications as well, related to the design and implementation of the network. So you can see there the yellow areas are the areas of encroachment. So you can see, it really does remove any of the subjectivity of deciding what vegetation needs to be trimmed back. The outcome of that, in 2023, there was around about 8,500 kilometers of network surveyed, able to achieve less than a 5% variance in between what was calculated from the digital survey and reality. So a significant improvement, and it's really helped kind of deliver that program and speed up that program. Subsequently, a similar number was captured again in 2024. And there will be a further survey again in 2025. So an ongoing project, something that's been successful and really shows you the different types of applications that technology uses. It's not just road surveys. I want to touch on a couple of other different ones here before we get into the Formula One stuff. So rail, again, an interesting one. This is actually Deutsche Bahn in Germany. Following successful trials of mobile mapping with Siemens and the MX-9 out there, they have actually now done a number of pilots and now are actually undertaking a project to model all of the railway in Germany to create a complete digital twin of the rail network in Germany. So, an absolutely phenomenal project which will produce huge amounts of data, which will really significantly impact the running of those assets. Now, unfortunately, here in the UK, we're a little bit behind in terms of the approval of different mobile mapping technologies for use on rail. I do believe that will happen, and it's going in the right direction. So we haven't done a huge amount in the UK. There was a project here where we worked with Murphy Geospatial on over in Ireland, which was the Dart line for Irish Rail. It's a 53-kilometre route that is undergoing upgrades. So they needed to survey the track quickly and efficiently. So we actually mounted the system on the front of a survey train, which means it stays within the envelope of the train, which is really important when you're doing rail projects. From that, we were able to capture, normal train operating speeds, full RGB 3D point clouds of the route. The route was surveyed in different directions to help build up that resolution and to also build up the accuracy. But we also used ground control based on existing surveys, and also where ground control could be implemented safely at stations and other areas that are accessible. And in addition to the point cloud, we were able to capture high resolution imagery. You can see here, obviously, the system has been rotated, how we would normally use it on a vehicle. This way it's facing forward on the front of the train. Again, can be used in either direction. And then from that, what we're doing is producing, again, a similar set of deliverables, CAD extraction, clearance reports of structures, And clearance is an area where there's more and more applications, and there's a lot of development recently in Trimble Business Center around segmentation and using AI for segmentation. So actually in TBC now you can build your own segmentation through AI. So if there's a particular part of the data that you're interested in, you can train it to find that for you automatically. And actually in rail here you can see that there is automatic tools for pulling out rails, sleepers and ballast. But then also within the Guido software, we can start to actually run clearance profiles through this data and extract the rail environment very, very accurately. Here, I just want to talk about kind of river and canal type surveys. Again, you saw in the picture earlier that mobile mapping systems are deployed regularly on boats as well. This was a project that Storm Geomatics and Geoterra undertook recently. You may have seen, actually using mobile mapping on a boat to survey the Regent's Canal Tunnel in Islington. A challenging survey. One, you're in a tunnel, so there's no GPS, and two, there's a need to survey both below and above the water. So what they did was firstly install a control network through the tunnel. This is critical if you're doing a kind of an underground environment or tunnel environment where you're not going to have GPS, because otherwise you're fully relying on the IMU and you will have drift over time. So having a control network really allows you to get that high accuracy that's needed. Then actually deploying an MX50 mobile mapping system on the boat, along with a multi-beam echo sounder to survey the full 870-meter length of the tunnel. The tunnel was surveyed in multiple directions, and then we needed to combine all the different data sets together. You can see there the LiDAR data from the tunnel itself. You can get a very, very clear picture of the surface of the tunnel, and actually the intensity ranging of the layers. It gives you a lot of information about kind of where you might have damp areas or different materials. So a real accurate kind of digital model of the tunnel. But really the excellent part of this project, I would say, is the combination of different technologies actually bringing together. Here you've got a point cloud from photogrammetry from a UAV captured, and then when you actually come down to the tunnel, you've got survey and point cloud information from an SX10 total station laser scanner of the portals, and then in the tunnel you've got the combination of the mobile mapping data and multi-beam echo sounder, all accurately coordinated together. And very much it is a combination of solutions often that we need to do. These are complementary technologies, and the accuracy in this project means that moving forward we'll be able to actually do repetitive surveys and actually try and understand variance and change in the structures. Okay, so finally, just come on to digital twins, and this is where I want to talk about Formula One. Formula One have an MX9 mobile mapping system. They undertaken a project of creating a digital twin of every GP circuit around the world. So their MX9 system goes to every race, and that information that they're capturing will be used for multiple applications. It could be used for planning, could be used for gaming, simulations, advertising, a very, very wide range of applications. There are historic data sets of different circuits around the world. However, there's a bit of a lack of provenance. Some of them have been surveyed more recently than others. Some of them are maybe surveyed by teams, some of them are maybe surveyed by the circuits themselves. So really what Formula One want to have is an up-to-date set of data that they've captured that is controlled and standardized. And the unique piece is really that they want data that is captured when the track is fully dressed and ready for race day. And that only really happens kind of 1 or 2 days before the race. There's a huge amount of work that goes on setting up a race. Obviously, you've got street circuits that might vary. You've got circuits that change. You've got differences in setup, in advertising, in structures. So every race is slightly different. And really what's needed here is an exact digital twin of what it is on race day. And that provides a number of challenges in itself, in that you've got a very, very narrow window of opportunity to actually capture this information. I was lucky enough to go out to one of the tracks myself. I went out to Suzuka in Japan, and there's a huge amount going on. And like I say, it's there's a lot happening on the track, off the track, and it is a very, very narrow window. So mobile mapping is ideal because we can capture at speed and we can capture a lot of information. This is a Silverstone, you can see here. But yeah, it's an ideal solution because we weren't just capturing the track itself, which generally is probably around 5 or 6 kilometers. We're actually capturing the access roads and the other roads around the environment to create a complete model. Also, what I found when we're out there is to get a complete picture, we really want to capture the track multiple directions. So generally when we do mobile mapping, we'll capture a road in 2 different directions. This is to help avoid occlusions or shadows. Now, generally the FIA don't like you driving the wrong way around a racetrack. So you do have to get special permission to drive backwards, but that's what we do. So we try and do a drive on the left, a drive on the right, and then drive in the opposite direction to get the most complete picture that we can of the track. Now, when I went out there, I kind of envisaged that the system would be put on a on a safety car, something like that. But in reality, that's not the case. We're actually tend to be using pickup trucks for a very valid reason. We want the system to be high up. We want to get a very good field of view for both the imagery and the LiDAR data. We are generally going to be driving very slowly because we want to maximize the point cloud that we capture. And yeah, there's a lot of planning that needs to go in because we're talking about doing 24 races in quick concession. The system has to go from one GP to the next GP, and then we get a very small window for survey. So planning is key on these kind of projects. Starts with actually, capture planning. How are we actually going to do the survey? So in advance of any race, Formula One will look at the route that they want to capture. They will upload that information into the system. So when they actually are capturing, they get a clear view of what they need to capture and what they've already captured to make sure that we get complete coverage. We also need to think about ground control. So to get the maximum accuracy possible, we need to have ground control around the track. And on race circuits, they have timing loops, and it's the timing loops that are positioned very accurately. So we've been using these as control to try and position the data very, very accurately. And the other challenge is RTK corrections. So here in the UK, we have VRS and other correction services. That's not always the case in every country. So in planning wise, we have to plan to have our own base station to set that up on site to provide corrections for the vehicle so we can optimize the positioning at a later date. And then the other piece is to think about the vehicle itself. Power is a big thing. Luckily, with Trimble Solutions, you can use standard batteries. You don't have to have a special battery, so you don't need to ship things around the world. You can actually, buy batteries in country, which is useful. But also, we're putting it on different vehicles each time. So we have to actually mount it on the vehicle, which is very quick, but there are certain measurements that we need to take. It's called lever arms, things like the height of the system, the distance from the system to the GAMS antenna at the front, which is a secondary GPS. All these things just help us optimize the accuracy of the data. So definitely pre-planning is key when it comes to these type of applications. You can see here then what we're capturing. So, we're capturing 360 panoramic imagery, raw point cloud data. We're actually capturing up to 25,000 points per square meter here. So very, very, very dense data. We've got then additional high definition imagery. So we have 3 high definition cameras, one of which is looking at the surface itself. So huge amounts of data that are being captured that we're then again uploading into a common data environment, into a cloud platform, which is very secure, which allows the different stakeholders within Formula One to be able to access this data and use it for the various different applications that it's needed for. There is some post-processing undertaken. So you can see there, I think that's Bahrain and Suzuka. So you can see how we've undertaken segmentation and classification. So we're actually classifying the track separately from the terrain, separately from the vegetation. We're removing noise, again, just to make the data more useful. And we also do have the intensity data as well. So generally, all systems will capture intensity, which is a really good, accurate way of seeing change in texture and materials, and something that's often used when we're extracting from the data. And there's also the imagery. So what we tend to do is take the individual images and combine those into a 3D video, 360 video. So this allows you to essentially do a bit of a digital site walk of the track. You could actually put this into a VR headset and walk around the track in a VR headset as well. So again, different ways of utilizing the data, but the objective here is really about, again, making it easy to use and extract for the use case that it has. And that way you get more and more people adopting the data. So you can see there last season, all of the circuits that were mapped, and Formula One are just ramping up now for the new season, which will kick off in March in Australia, in which all of the circuits will be mapped again. And the interesting piece next year will be, because we will have 2 seasons of mapping, we'll be able to actually understand change. And that's where we'll start to look at different routines that we can run to actually identify very quickly and easily the variance between the tracks. And then that information can then feed into the various different stakeholders that need that information to update the digital twin that's kept on record. So yeah, really interesting project. You know, fascinating to see how that whole piece works. It's very much traveling circus. The amount of people, you could have 3,000 people on a circuit there setting up is huge. So certainly the mobile mapping, while it's fast, the logistics of it are challenging, and it's great to see the results that have come off that project. So just finally then, we've got 5 minutes. So just a quick summary from my side. So I suppose what I'm trying to get across here is that mobile mapping, it is now widely adopted. It's not niche anymore. It's come a long way. It can be used to have massive impact on projects, whether that's speeding up the projects, reducing the cost of projects. It's not limited to roads. You can see they're commonly used on boats, trains, quad bikes, you name it. Again, makes it a very, very versatile technology. But really, like I've just shown there, the key is in getting the value from the data. And I think that, using the AI tools there to extract information is key, but also really sharing and hosting that data and sharing it with your customers and getting the most out of the data is one of the biggest shift changes in the industry, not just for mobile mapping, but for all mass data capture technology. And like I showed with some of the projects there, it's just another tool. It's there to be used in conjunction with other techniques. You're not going to stop doing everything and just mobile map everything, but it's another tool in the toolbox to really help us capture and create those digital representations of reality as efficiently as possible. It's never been more accessible. Price points of mobile mapping have come down a lot in recent years, so it's very much a technology that can be purchased now, but also from a KOREC perspective, we try to make it accessible also through hire and services. Those services could be data capture services or processing services or both. So, if you have a project and you think mobile mapping could be suitable, please do reach out and we'll be happy to talk to you about how you could utilize it for your project. And like I say, that's at the end, don't be left standing still. Technology is moving fast. Embrace technology, and it will really help you move forward on your projects or within your own business. So with that, I think we're doing okay for time. So if there's any questions, I will do my best to answer them. So let me have a quick look here. So accuracy dimensions on potholes. So someone's asking there about how accurately we can measure the potholes. So if you remember, originally we've been using imagery for identifying the potholes and the other defects. So with that, we're really just getting a positional accuracy, which is the accuracy of the survey that we do. So that could be, if it's the ground control, it could be kind of sub 10 millimeters. Now, if we want to actually understand the depth of the pothole, that's where we really need to start utilizing the LiDAR information as well. Depending on the system, the precision of the LiDAR data will be about 2 millimeters. So in theory, you can see relative variation down to 2 millimeters. It is one of the kind of development activities and tasks and things that's being researched at the moment is, you know, can we, once we've positioned the defects, can we start adding additional attributes from the laser information, such as depth or area. Another one that comes on quite a lot is kind of, you know, where you've got joints, say in the concrete roads, you know, how much variance can we see between joints or heights. So yeah, it's, so far we haven't been using it for that, but actually it's definitely an area that can be used. So I'm trying to see if there's any other questions. From my perspective, would I class the point cloud as a product itself, which could be sold? Yes, I would say. Like I say, I think the point cloud itself is very much a deliverable, and I think, like say, the platforms that are available now to share that information really allow people to access it and use it. And I think quite often when we're creating a drawing or a model, we're losing a lot of that information. We're generalizing. So actually, in many ways, it's often better to work directly from the point cloud itself. So yeah, definitely, and there's tools out there to help you do that, and actually, you know, things like the segmentation really help that. So I'd recommend that, and there's a lot more people directly using the information from the point cloud data directly. There's a few different questions here. I'm just trying to. Okay, I don't know if there's any other question. I think there is some there, but they're not popping up for whatever reason. But I think I've answered most. Any industry standards to guide to best practice? Good question. I think there's best practice for mobile mapping, and there's best practice for the information that we extract. I think when it comes to mobile mapping, I think up until recently, a lot of projects have been specified to be done traditionally and then been done by mobile mapping. Whereas what we are now actually seeing is we're seeing more and more projects specified for mobile mapping. So actually, it's been done to a specification, which I think does help standardize what's being produced. I think there's probably best practice that's followed in the industry, but it's probably lacking, you know, some commonality in documentation. We've done quite a lot of work with Cambridge University and the digital roads team there that have been looking at, particularly around digital twins for highways, linked to that kind of digital agenda that national highways have. And you know, I think that kind of work really helps and might filter through, particularly again, and that's really about defining what the digital twin is. So there's kind of how you capture data, kind of what the deliverable is, but then what is a digital twin? You know, is it a point cloud, or is it actually a textured mesh? Is it a CAD model? You know, if you do that survey again, then you know, how do you update it? How do you manage change? And if you've got data coming in from 4 different sources, how do you decide which one's right? So it's definitely an area where, you know, standardization is needed and will be needed as we do more and more of this. Some of the objects look very clean. Is there noise removal? So yes. So noise removal is used. So we within Trimble Business Centre, there is automatic segmentation, which will remove transient objects and noise. It's not always perfect. Like most systems, there's always an element of some cleanup. but it'll do a pretty good job of removing that data. Other things which generally will happen as standard is blurring. So particularly if you're doing projects that are going to be in the public domain, there's a requirement to blur people's faces and number plates. So again, in the software, there is tools to help you do that. And obviously GDPR and things like that are really important these days. So it's imperative that we have these kind of tools. And again, things that are using AI, you're using AI tools for that kind of process. So I think the AI piece is really speeding up what you can do. One of the recent developments in TBC that came out in the last version was fully automatic white line extraction. So not even actually clicking on the line, purely looking at the AI will look at the data set and extract the white lines. If you can extract white lines automatically, you can identify lanes automatically. If you can identify lanes automatically, you can then start looking at pavement condition and roughness automatically. So the workflows are optimizing all the time in terms of how we go from mass data to deliverables. I'm trying to see, I've only seen what was the most recent question, so I'm just trying to see if there's any other questions there. Can we access some of the demonstrator data? Yeah, so we can certainly make some of the data available. Obviously, for certain projects are restricted, but some projects we can share data. We do have sample data, particularly for the new MX60 solution. So if people want to see some mobile mapping data, whether that is point cloud or imagery, we can share that with them. What I'd also say is soon we'll be able to share with you a demo data set in the Solvo platform, where you'll actually be able to go in and view the data and download it, but also see how the data can be accessed in the platform. Furthermore, we do have a roadshow, so keep your eyes peeled on the socials. We are taking the new MX60 mobile mapper on tour in the next couple of weeks. So if you would like to see a face-to-face demonstration of the technology and have a look at some of the data, please do register for the roadshow. We are going to be all around the country. We'd love to come and see you, show you the technology firsthand, and actually show you some of the data as well. So please do sign up for that. Like I say, any other questions, my email is there on the screen. Feel free to drop me an email, reach out to me, and I'm happy to help and discuss. Like I say, from our perspective, this technology is here. It's never been more accessible, and we're keen to work with people to start implementing it in your projects. Okay, I think we're probably just coming up on time. I think I've answered most of the questions that are there. Like I say, if there is anything else, please do fire them through. Hopefully it's been a informative webinar. Hopefully you've taken away something from it, and yeah, please get in touch with anything else. And like I say, we will share the slides afterwards, and also I believe the recording will be available on the CICS YouTube channel. Thank you very much.